Hello everyone, welcome to telecommunications program. So in this session we will talk about spectrum used in telecommunication. Most of us would have heard the word spectrum, 2G spectrum, 3G spectrum or 4G or even a 5G spectrum. Let's try to understand what the spectrum means. And also when we would have purchased the phone, uh, we would have seen the mobile specification where what are the network technology that are supported by the phone, and there are different bands like 2G, 3G, 4G and 5G, and there are specific numbers associated with these bands. Let's try to understand what these numbers are. What do you mean by spectrum? Spectrum is nothing but a radio frequency allocated to the mobile industries and used by the other industries for the communication over the air interface. And the radio spectrum in short is known as RF, radio frequency, which is nothing but an electromagnetic wave. And some of you might be aware of this frequency range of this electromagnetic waves ranges from 30 kilohertz to 300 gigahertz. So this 330 to 300 gigahertz is split up into the various ranges, starting from the high frequency to a very high frequency, ultra frequency, and a long wave, short wave. And you have different bands like LSC, X, Q, K and K, B and MM. Let's try to understand where these frequencies are used and for which applications, and why this spectrum matters a lot. Because the radio spectrum is used extensively in our day-to-day life for different means, for radio broadcasting, for mobile phones, Wi-Fi communications, GPS, radar, etc. How do you measure a spectrum? The spectrum is measured in terms of hertz. That's a unit of measurement of frequency. So we have different scales like kilohertz, megahertz and gigahertz, and you see the different applications of this frequency used. For example, 3 kilohertz to 30 kilohertz range is used for maritime radio navigation, and uh, from 300 kilohertz to 30 megahertz is used by AM radio and the shortwave radio, whereas 30 to 300 megahertz is used for the television and mobile phone, ranges from 300 megahertz to 30 gigahertz. And the higher frequencies are used for the satellite communication as well. Okay, so who are the spectrum users? There are different types of spectrum users. For example, the major categorization is into two types: licensed spectrum and unlicensed spectrum. So licensed spectrum is used in the weather radar, military security system, global positioning system, satellite broadcasting and communication, mobile services, and etc. And unlicensed spectrum, so which we use on for TV remote controls, microwave ovens, X-ray machines, the Wi-Fi, cordless phones. In a 2G network where GSM is used, it is operated in the ranges 900 megahertz, 800, 850 megahertz, 1800 and 1900, and most of the 3G network operates in 800, 850, 900, 1700, 1900 and 2100 megahertz band. So let's talk about the relation of this frequency and the wavelength. Why it is so important to understand this relation? If you see the formula of the frequency and the wavelength, the speed equal to wavelength into the frequency, V equal to F into lambda, where f is a frequency and lambda is a wavelength and v is the speed of the wave. So on this diagram you see the low frequency wave as a long wave and a high frequency wave as a short wavelength. So what it means, both frequency and wavelength are related inversely, meaning the lower frequency can travel a long distance compared to a higher frequency. In this, for example, 800 megahertz frequency can travel more distance compared to a 1000 megahertz band. So obviously everyone thinks that now, do operator use a low frequency for a good coverage? Yeah, let's get into the details of that in a next slide. Not necessarily operator needs to use a lower frequency always, though we have advantages of lower frequency that can transmit a long distance, but there are advantages with higher frequencies or the higher bands. The wider the frequency bands and the channels, more information can be passed on. Assume a situation where you have a wide road where you can have more vehicles can traffic can go through the wider roads, whereas if it's a smaller roads, consider this wider roads to be a higher frequencies, whereas the narrow roads to be a lower frequency where the traffic can be less. So that's the reason the higher the newer technologies 5G or 4G uses the higher bandwidth or the higher frequencies where you can accommodate more traffic, though we have a limitation in terms of a longer distance coverage. So it has to go with a trade-off, and also we have this higher frequency broadcast have a less interference from the electronic sources, whereas lower frequency are less interference from the physical objects. Hope you understood about the spectrum concept. I think if you have still questions, you can drop me the questions in the comment section and I will answer you in the upcoming sessions. Thank you.